Good day, grade 9. Here is your reviewer in Mathematics 9 for third quarter, part 1. Question number 1. MALE is a parallelogram. MA equals 9 centimeters. Find the length of LE. So remember that for a parallelogram, the opposite sides are congruent. So therefore, we can say that MA here is congruent to LE. So we can write it down as MA is congruent to LE. But since they are congruent, then their measures are equal. So MA is equal to LE. And MA is 9 centimeters. So since MA is equal to 9 centimeters, then LE is also 9 centimeters. So therefore, the answer is the length of LE is 9 centimeters. And that's the answer. For question number 2, GIRL is a rhombus. If GI equals 6x minus 4 and LR equals 4x plus 8, find LR. Since our quadrilateral is a rhombus and the sides of a rhombus are all equal, then GI here is equal to LR. Since GI is equal to LR, so we can write GI equals LR. Then we can substitute GI with its length, which is 6x minus 4. So substitute GI with 6x minus 4, and we substitute LR with its length, which is 4x plus 8. And from here, we are going to solve for x. And consequently, later we will find LR. So, since 6x is similar to 4x, then we can move or transpose 4x to the side of 6x so that we can combine them as similar terms. So it will become negative 4x now. And we also know that negative 4 is similar to 8. So to combine negative 4 with 8, then let's transpose 4 also, or negative 4, to the other side of the equation. So it will become 8, and negative 4 becomes positive 4. So we have 6x minus 4x, which is equivalent now to 2x. And 8 plus 4 is 12. Solving for x, so we have to leave x alone by dividing all parts of the equation by the coefficient of x, which is 2. 12 here divided by 2. So you can cancel out 2. So x is equal to 12 divided by 2 is 6. Now, after solving for x, we are now going to substitute the value of x to the length of LR, which is 4x, but x now is 6 plus 8. So we have, simplifying further, we have 4 times 6 is 24, 24 plus 8. But 24 plus 8 is 32. So therefore, the length of LR, or LR, is equal to 32. And that's the answer. Now, for question number 3. The measure of one angle of a parallelogram is 30 degrees. Find the measure of the adjacent angle. So before we solve that, let us draw a typical figure of a parallelogram. It looks like this. And one of the angles is 30 degrees. Here. Now, what is being asked is the angle which is adjacent to this 30 degrees here. So, since based on the properties of a parallelogram, the adjacent angles are supplementary. So, when we say supplementary, the sum of the two angles is 180 degrees. So if the sum of this angle, let's say this is angle X, and this 30 degrees is 180, then we can say that X plus 30 degrees is equal to 180 degrees. Now, just imagine if you already have a 30-degree angle and you are uh, going to have a sum of 180 degrees. How many more to make it 180 degrees? So you can subtract 180 minus 30 degrees. But 180 minus 30 is 150 degrees. So therefore, the measure of the angle adjacent to 30 degrees is 150 degrees. So that's the answer, 150 degrees. Now for the next question, two opposite angles of a parallelogram have measures of quantity 3x minus 30 degrees and quantity x plus 10 degrees respectively. Find the measures of the angles. Again, let us draw a typical figure of a parallelogram. And one angle has a measure of 3x minus 30. So we have to label it 3x minus 30 degrees. And the other angle, which is opposite to the first one, is, let us label it as x plus 10 degrees. Now, another property of a parallelogram involving its opposite angles is that the opposite angles of a parallelogram are congruent. So since this angle, let's say this is angle 1 and this is angle 3, are opposite, therefore they are congruent. And since they are congruent, their measures are equal. So we can equate their measures, which is the first one, 3x minus 30 is equal to x plus 10. And commonly for equations, to simplify them, we combine similar terms. So in this case, 3x and x are similar terms. So we combine them, we get 3x, and to move x to the other side, we transpose x. So we have 3x minus x now equals, you also combine or transpose 30 to the other side of the equation and combine it with 10. So you will get 10, and since 30 is negative originally, it will become positive 30. So since 3x and there is understood 1 here minus 1x, then you get 2x equals 40. And to eliminate the coefficient of x, you have to divide all sides by 2. So 2x over 2 equals, of course, you also have to divide 40 by 2. So you have x equals 20. So to find the measures of the angles, we just have to substitute the value of x that we have computed to any one of these measures. It could be for 3x minus 30 or x plus 10. Any of them will give us the correct measure of the angle. So let's just use x plus 10. So x plus 10, quantity, degrees. But x is 20 plus 10 degrees. But 20 plus 10 is 30 degrees. Therefore, the measure of these identified angles, this one and its opposite, is 30 degrees. So this is your answer. Next question. The diagonals of a rhombus are 6 and 8. Find the length of its sides. So remember that for a rhombus, the sides are all equal. Another property involving its diagonals, the diagonals are perpendicular and they bisect each other. So let's draw the diagonals here. But since the diagonals are perpendicular and they bisect each other, so these two diagonals here form right angles. They form 4 right angles. So allow me to label these four right angles with the small squares. And since they bisect each other, they divide each other into halves. This 6 here becomes 3. And the other half is, of course, 3. And 8, the measure of the other diagonal, becomes 4. And the other half is also 4. Now, since you have formed 4 right angles, this right triangle, I should say, this right triangle, another, then third one, then fourth one. Let us take one right triangle. And so the sides of this right triangle are, we take one of the half of the diagonals, which is 3, and the other half is 4. And this is the side of the rhombus. We do not know if how long it is, and we are going to solve for it. But since you have formed a right triangle, and to solve for the sides of a right triangle, we use Pythagorean theorem. Pythagorean theorem. So by Pythagorean theorem, by PT, PT stands for Pythagorean theorem, a squared plus b squared equals c squared. So let's just assign a for 3. Yeah. So let's take a as 3. So 3 squared plus b 4 squared equals c, which is the side of the right triangle taken from the rhombus. So s squared. So we have simplify. 3 squared is 9 plus 4 squared is 16 equals s squared. But adding 9 and 16, you get 25, which is equal to s squared. Now we just need a simple s or side. We do not need s squared. So to get rid of this exponent square here, apply the square root to both sides of the equation. So the square root of 25 is 5, and the square root of s squared, of course, since s or square here and square root are inverses, they cancel each other out. So what has remained is only s. So s is equal to 5. Therefore, the length of the sides of a rhombus is 5. And that's the answer. 5. Now let's move on to the next question. The scale of a map is 1 centimeters is to 2 kilometers. So what map distance corresponds to the actual distance of 12 kilometers? So remember, a map is this small representation of the actual place. So in the map, 1 centimeter represents 2 kilometers. So what if in the actual place it is 12 kilometers? So what should be the distance of that place in the map. So to solve that, just use the ratio and proportion. Just use 1 centimeters is to 2 kilometers. So in the map, we do not know if how far is it or how far is 12 kilometers. So we just represent it with x. X centimeters is to 12 kilometers. In applying the product of the extremes is equal to the product of the means, so you get 2x equals 1 times 12 is still 12. Dividing all sides by 2 to get x, so you have 12 equals 12 over 2, which is 6. So 6 centimeters. So in the map, you see a 6 centimeter distance, but in the actual place, it's already a 12 kilometer distance. So the answer is 6 centimeters. Next question, duplicate. Okay, next question. The lengths of the bases of a trapezoid are 14 centimeters and 6 centimeters. The length of the median is blank. So let us draw a figure of a trapezoid. So the bases of this trapezoid are given as 14 centimeters and 6 centimeters. Remember that the median is the line segment that joins the midpoints of the non-parallel opposite sides of the trapezoid. So let's just assume that this one is the median, and it passes through or it joins the midpoints of this side, or the left side and the right side. Let's just say that this is M, stands for median. So remember that the median of any trapezoid is given by the formula 1/2 times the sum of the two bases. Let's say base 1 plus base 2. So the median of this trapezoid, by substituting base 1 with 14 centimeters, or let's just for the meantime write it as 14 without the unit. So 14 plus 6, the two bases. So median M equals 1/2 of the sum of 14 and 6, which is 1/2 of 20. But 1/2 of 20 is 10. So therefore, the median is 10 centimeters. And that is the answer. Okay, next slide. HART, as shown in the figure here, is a rhombus. The measure of angle T equals 40 degrees. So find the measure of angle R. If we look at our rhombus, here is your angle T, and it has a 40-degree measure, and here is your angle R. Remember that for a rhombus, the consecutive angles, any consecutive angles of a rhombus are supplementary. Since angle R and angle T are consecutive, then their measures will have a sum of 180 degrees because they are supplementary. So we can say that the measure of angle T plus the measure of angle R is equal to 180 degrees. Now, since angle T is 40 degrees plus measure of angle R equals 180 degrees. Let's just transpose 40 to the other side of the equation to combine it with the term 180 degrees. So therefore, measure of angle R is 180 degrees minus 40 degrees. And finally, measure of angle R is 180 minus 40 is 140 degrees. And this is your final answer, 140 degrees. Next question. If the diagonals of a trapezoid are congruent, then it is an or a blank. So there is a special kind of trapezoid which is called isosceles trapezoid. For isosceles trapezoid, the non-parallel sides are congruent. Non-parallel sides are very ugly, are congruent. Okay, so if we have trapezoid here, these are the sides which are parallel, and these are the sides which are non-parallel. The left side and the right side are non-parallel. The upper side and the lower side, or we call them bases, are parallel. So the non-parallel sides of an isosceles trapezoid are congruent. Also, their diagonals are congruent. So the diagonals of a trapezoid are congruent. Therefore, if the diagonals of a trapezoid are congruent, this is called an isosceles trapezoid.